Let's look at how we can write a sine equation and a cosine equation that corresponds to a given graph. Okay, and so just to remember, the format for those equations would be y equals a times the sine of k times the quantity x minus b, closing the quantities, and then plus c. Or for cosine, it'd be y equals a cosine of k times the quantity x minus b, and then all that plus c. So there's the same formulas. We just have to figure out whether we're dealing with sine or cosine. Okay. There's um, a number of ways we can do this. I'll just try to kind of follow what we did, just sort of in reverse when graphing the functions. So we'll kind of look at where there's a box that surrounds or encapsulates one period of our graph. And then from that box, from that part of the graph, we can figure out the values for the A, the K, the B, and the C. Okay. And again, just as a quick review here, a normal curve, a normal period for sine starts at the midline, goes up, down to the minimum, and back to the midline. So this is sine. And again, for cosine, it starts at the maximum, goes down to the minimum, and back up to the maximum. So that's cosine. So let's do a few examples here. We'll start with start with the sine graph, I guess. And one thing to remember too, when you're looking at a graph, because the graph is periodic, there are actually infinitely many ways we could write this equation, just depending on what we choose for the rectangle, where we want it to start. Okay. So to try and get started here, let's just kind of break our graph into parts. So we have this sine wave here, and I'm going to draw a line across the top. So here the graph hits a height value of a 1. And I'm going to do the same thing at the bottom. So the minimum of the graph is at a negative 5. So what is halfway between 1 and negative 5? We can kind of visualize that off the graph. That's going to be a negative 2. But we could also compute that. And if you remember, the middle of the graph is our midline, which is our C value. So to find the value for C, we can take whatever our maximum value is, add it to the minimum value, and then divide by 2. So in this case, we're going to take a 1 for the maximum plus a negative 5 for the minimum divided by 2. 1 plus a negative 5 would be a negative 4 divided by 2, and so negative 4 over 2 would be a negative 2. So our C value is a negative 2. To figure out the amplitude, once you know where the middle of the graph is, the amplitude is just the distance from the middle up to the top or from the middle down to the bottom, which, again, visually we can just look at the graph and tell that that distance is a distance of 3. But we can also figure out the amplitude using the formula max minus min over 2. So 1 minus a negative 5 over 2. 1 minus a negative 5 becomes 1 plus 5, or 6 over 2. And so the amplitude is 3, which we kind of, again, already visually knew. All right. So that gives me the outside values, the A and the C. To figure out the inside values, the K and the B, we need to go ahead and locate what period of the graph are we talking about. So I'm going to look for the closest place where the graph touches the midline. The closest that place is to the y-axis. Okay. I could go to the left or to the right, but in this case, it looks like it crosses the x-axis, or sorry, it looks like it crosses the y equals negative 2 midline, just a little bit to the left of the y-axis. Okay. And the scaling of the graph that I have here, every 2 horizontal bars is pi, which means each horizontal bar is pi over 2. So this left edge of the graph is at a negative pi over 2. And so to find the right edge of the graph, we're going to start here, and we're going to go up. We're going to go down to the minimum, and then back to the midline. So right there's the end of the graph. And where is that? So that's between 3 pi and 4 pi. So 3 pi would be 6 pi over 2. 4 pi is 8 pi over 2. So this would be at 7 pi over 2. Okay. So that tells me the start and the end, the top and the bottom of my graph. So from that, I can figure out the period. So to find the period, there's a couple ways we could get that too. We could just use the box. So if we're going from a 7 pi over 2, and we're starting at a negative pi over 2, I can subtract those. So 7 pi over 2 minus a negative pi over 2 becomes 7 pi over 2 plus pi over 2. And that's 8 pi over 2, or 4 pi. Okay, so my period is 4 pi. Another way that we could do that is if you look at two maximums or two minimums. Okay, so for example, one maximum occurs at pi over 2, and another one is going to occur out here at 9 pi over 2. So how far is it from 1 pi over 2 to 9 pi over 2? That would be 8 pi over 2, which again is just 4 pi. So it's the same thing. Okay, you can also do that with two minimums. Say from the minimum here at a negative 3 pi over 2 to the next minimum at 5 pi over 2. So from negative 3 to positive 5 is a distance of 8. Okay, so there's different ways we can do that. Once we know the period is 4 pi, we can figure out k. So the k value is going to be 2 pi over our period, which is 2 pi over 4 pi. And the pi's cancel out, and 2 over 4 becomes a half. So we know k is a half. So we have our k value, we have our c value, and we have our a value. And we actually already have b. It's the left edge of our graph, so it's that negative pi over 2. Okay, so to write out our equations, we'll have y, at least the sine graph, will have y equals, what was a? Amplitude was 3 sine of our k value, which is a half, times the quantity x minus b, and since b is negative, it's going to become plus pi over 2. So my start of the graph is to the left of the y-axis, and then plus our c value. C is negative, so we have minus 2. So y equals 3 sine of 1/2 times the quantity x plus pi over 2, and then all that minus 2. Right, that would be our sine graph. If we wanted to do cosine, most of this will be about the same, but remember cosine starts at the maximum. So here's our maximum at pi over 2, and we hit another maximum at 9 pi over 2. So there's the left edge and the right edge. The top and the bottom and the midline all stay the same. So we're going to use the same values for A, C, and K. Those haven't changed. The only thing that changes is where we start the graph. So in this case, I'm starting the graph at pi over 2. So if I wanted to write cosine, it still has an amplitude of 3. The curve hasn't changed. It's cosine now. The period is still the same, so we're going to have a half x. So where does the graph start? It starts at a positive pi over 2. So I'm going to have x minus pi over 2, and then minus 2. Okay, so these are just two options. Again, the answers can vary depending on where you want to draw your box. Okay, and if you look at, there's another cosine over here. So you could go from here to the pi over 2. And same thing with sine. So there's different ones we could use. We could also start with a reflected sine or reflected cosine and go through it. Okay, but for now, these are two functions that would describe that graph that we're given. Okay. All right, let's try another one. So we're going to do the same process. We're going to start by finding our maximums. With this graph, the maximum is at 8, and our minimum is at a -2. Okay, so from that we can find the midline. Remember, the midline is the max plus the minimum over 2. So 8 plus a -2 over 2 would be 6 over 2. So our midline is 3. So if we draw that in there, that definitely looks like it is right in the middle. Our amplitude is going to be the max minus the min over 2. So 8 minus a -2 over 2. Take care of the signs. That's going to become 10 over 2, which is 5. And so if we look at our graph, from the midpoint, we're going to go up 1, 2, 3, 4, 5 up to the top. And we're going to go 1, 2, 3, 4, 5 down to the bottom. So the amplitude and the midline do seem to match up. All right, next, let's try and find our period. Okay. So again, there's several ways that we could do the period. We could finish drawing the box. Instead, this time, let's just go from max to max. So the first maximum starts at 0, and the second maximum is going to be right here. So what is the x value for that? So from 0 to 1, there are 1, 2, 3 boxes. So that means each box is a distance of a third. So 1/3, 2/3, 3/3. So this is actually at 4/3. Okay, so my graph goes from a maximum at x equals 0 to the next maximum at 4/3, which means the next maximum will be at 8/3, and so forth. If we went to the left, it has a maximum at a -4/3. Don't let the fractions throw you off. So that means my period, the period is the distance from maximum to maximum, because that would be the length of what cosine looks like. So in this case, my period is 4/3. And from the period, we want to find k. K is 2 pi over the period, so 2 pi over 4/3. And so k is going to be 2 pi times 3/4. And that is going to be 3 pi over 2 when we multiply and simplify. So we know our a value is 5, we know c is 3, and we know k is 3 pi over 2. Okay, so those three values are always the same, regardless of where we start, where we end, whether we're doing sine or cosine. So I always find those three first: the a, the c, and the k. The b value can change. So let's try and start. So let's do sine here. Again, sine, if you remember, sine starts at the midline, and if it's not reflected, it goes from the midline up. It increases. So from the midline up to the top, then down to the bottom, and then back to the midline. Okay, so there are multiple places. We could start here. We could start here, here, or here. Those are all places where the curve is crossing the midline, and it is increasing as it goes. Okay, so and we just need to pick one. And it doesn't matter. So let's just go with, since this is at a whole number, let's do the first time it hits the midline. Let's pick another one. How about this one here? What's different about x at the point where it hits the midline at x is 1/3? Here, if we start at 1/3, the graph is going to go down, but it's normally supposed to go up. We're going to end there. Okay, so if we start here and end here, so we're going from 1/3. What's the end point? 1/3, 2/3, 3/3, 4/3, so 5/3. Okay. Because we're starting at the midpoint and going down, that means I'm actually using a place where the graph is reflected. That's why I wanted to pick that one. Okay. So my sine graph is going to be y equals, my amplitude is 5, but because I picked one where it goes down from the starting point, it's reflected. So I'm going to make it a -5. And then the sine, okay, we have our k value, which is 3 pi over 2, parentheses, x minus. So what is the x value at this starting point that I picked? It's 1/3, so positive 1/3. So x minus 1/3, close our parentheses, and then our shift was up 3. So this particular equation that I have is y equals -5 sine 3 pi over 2 times the quantity x minus 1/3 plus 3. Okay, and again, that's because it's shifted 3 units up. Its amplitude is 5. The period was 4/3, which when you combine that with the 2 pi, it gets this 3 pi over 2 fraction. I'm starting my graph at 1/3, which means I have the x minus 1/3 here. And because the graph at 1/3 starts to go down to the minimum instead of up to the max, I have to make it reflective. Okay. And again, there are other options I could have picked. I could have started at a -1/3 and it would have gone up. Or I could have started at x equals 1, which was kind of my first idea, is to start at x equals 1 and the graph does go up. Okay. But I wanted us to see what it looks like to start where it is reflected. Okay. All right, let's try cosine here real quick. Again, for cosine, remember the a, the c, and the k value all stay the same. Cosine just starts at the maximum. So the maximum is actually on the y-axis, which is nice. And so here's my cosine graph is going to be from 0 to 4/3. Okay, there's my cosine graph. Okay, so it's going to start up here. It's going to go down. It's going to come back up to the top. Okay, so my cosine graph is y equals, since I'm starting at the maximum, I am not reflecting it. So it's going to be +5. Cosine, the 3 pi over 2 stays the same. The b value in this case is 0. Okay, so I actually don't need to put anything here. I can just say it's x. It's technically x minus 0, but again, we don't need the 0. So I only need one set of parentheses and then plus 3. Okay, so again, these are just two examples, two possible answers that we could end up with for this example. What changes? So the 5, the 3 pi over 2, and the 3 don't change if we use a different portion of the graph. The only thing that could change is where do you start, so that's the b value, and then whether or not it's going to be reflected. That's the negative, whether it's positive or negative. All right, let's do one more, and then we'll be done. This time we're actually going to look at what if we're given, instead of a graph, what if we're given a table of data? Okay, so in this table of data, we have values for x in our x column starting at 2 and going up to 60. So values from 2 to 60, and they vary in terms of the increments. And then our y values, they start at 20. So the point 220 is our first coordinate. And then we have 623. So it went from 20 to 23. So it's going up. And then from that 23, it's going to go all the way down to 17. So the point 1417. And then it's going to go up to 23 at 22, 23. It's then going to go back down to 17, back up to 23, back down to 17, up to 23, and so forth. Okay, so just looking at the values in the data, the y coordinates, we can see that our maximum is the 23s. It's the highest these values ever get. Okay, so our max is 23. Same way we can look at the minimums. The lowest it ever gets is 17. Okay, So our minimum is 17. So that means if we just wanted to see kind of a quick sketch of this graph, it starts sort of when x is 2. It starts at 20, and it goes up to 23, and it goes down to 17. So it's going to do something kind of like this. Okay, so we know the top of the graph and the bottom of the graph. Okay, so because we know the max and the min, we can now find the value of A and the value of C. So remember, C is max plus min over 2. So 23 plus 17 over 2. 23 plus 17 would be 40. So 40 over 2. So the C value is going to be 20, which we actually see that here when we start, which is nice. And then we see it again later on around x equals 43. And that's the only time we see 20s in there. That doesn't mean there aren't 20s in the actual graph, okay? Because if we look at the values, 20, 23, 21, and 18. From 21 to 18, it has to pass through 20. So there's a 20 somewhere between this 21 and 18. We just don't actually have it in the data. That's fine. If we needed it, we could make a guess, an educated guess, right? An estimate. So let's find A. Remember, A is max minus min over 2. So 23 minus 17 over 2. 23 minus 17 would be 6. So 6 over 2 is 3. And hopefully that makes sense. If the middle of our graph is 20, if you go 3 units above 20, you hit 23. And if you go 3 units below 20, you get 17. And that matches what we were talking about in our graph there. Okay. Next, let's find the period. So to find the period, again, there's several ways we could do it. The easiest method usually, again, is to find the location of 2 consecutive maxes or 2 consecutive mins and just find out how far apart they are. So my first maximum occurs when x is 6, so that's the point 623. My second maximum occurs at the point 2223. So how far is it from 22 to 6? So just subtracting. 22 minus 6 would give us 16. So my period is 16. And if the period is 16, remember k is 2 pi over our period. So we're going to have 2 pi over 16, which is going to be pi over 8. Okay, so I know C, A, and K. So C is 20, A is 3, and K is pi over 8. Right? So if I want to write a sine and a cosine graph, remember sine, we've talked about this a couple times, sine starts at the midline and it goes up, down, and back to the midline, assuming it's not reflected. Okay, and we could reflect it if we want. If we reflected it, it would start at the midline and it would go down and up and back to the midline. So that's our reflected sine. So let's look for my midline is 20. Where do we hit 20? I usually like to find the first time it happens. Well, the nice thing with that is the first time it happens was the very first point. Okay, so if I want to do sine for y equals a positive sine x, I'm going to use b is equal to 2 because that's where it's at the midline. Okay. The other thing I have to look at is it increasing or decreasing? So from this 20 to the 23, that is actually an increase. Okay, it's going from 20 to 23. So that's what I'm seeing here. Okay, I'm going from the midline of the graph upwards towards the maximum. Okay, so I want to use the positive value. So my sine equation is going to be y equals 3 sine of pi over 8 times the quantity of x minus 2, and then all of that plus 20. All right, let's try it for cosine. So for cosine, again, the a is 3, the c is 20, k is pi over 8. Those don't change. But this time, remember, cosine starts at the maximum and ends at the maximum, so it hits the minimum in the middle. Or, so that's cosine, or if it was reflected, it would start at the minimum, go up to the max, and then back down to the minimum. So this would be negative cosine. So again, the only way I just need to figure out where's the maximum or where's the minimum, and I can go from there. Well, again, it turns out that I have a maximum of 23, and that occurs when x equals 6. So I could just use b is equal to 6. And since I'm at the maximum, I don't have to reflect it. So my equation is going to be y equals 3 cosine of pi over 8 times x minus 6, and then all that plus 20. Okay, so that's how we can find a sine and cosine graph from the table of data. And again, how we do that, the a values, the c values, and the k values don't change whether you're doing sine or cosine, and they don't change where you're starting your period or graph at. All that changes is the b value and whether or not you're going to have a reflected graph, so whether the coefficient is going to be positive or negative. All right.